Once again, good morning, everyone. It's a pleasure to be here. I'm Victor Odumiwa. I've been introduced, and I'm an associate professor, Department of Computer Science, University of Lagos. Yeah, so I gave a bit of introduction and talking about my research, explaining what has been my focus over the past few years. And I said, coming back from right from my PhD, while I worked on collaborative information retrieval, I've always seen that the problem is about semantics. If you want the machine to serve us better, it's about semantics. So that's been the major problem. And so several work have been done in this area of semantics, starting with metadata. How do we describe any document to the machine? How do we describe information to the machine? And now we're in the era of embeddings, where we can create vector and we can represent what relationship between documents, between words, between sentences, between audios, between videos, all those things can be done now without even putting metadata because of the power of, well, it started with RNN, that's recurrent neural network, then moving to LSTM, then transformer, and all of the architectures that came up after that. So, and that has informed my work, because if machine can understand human, a lot of things can be done. So for today, is just to talk about insight from unstructured data. And yeah, so still go back to very good. Imagine a machine that can understand not only text, but also context. So we're not talking about even just understanding the document alone now, but even the context around it. So a lot of things are happening on how do we really understand the world? How can machine understand the world? For us, naturally, it's very simple. As human beings, our neurons are working fine. So you see, it registers. I know you've heard about talking about AGI. Yeah, we're still far away. Yeah, even though some people are claiming we're very close, we're still far away. All is about if machine can properly understand the world, then that is it, and then can take decision. Yeah, but it all started from text. So if you understand text and understand context, then you can be able to make some decisions. So in natural language processing, which I don't think will be strange to anybody here, does the same thing. We want to be able to process the way human beings process information. Yeah, or that's textual. Before we limited it to text, but today we've gone beyond text and say, okay, all forms of information, audio, video, how can we process, how can machine understand, get the semantics of what it's all about. So we're not just talking about text, we've gone beyond text. Okay, so let's go to the next line. So many things have happened that led to the kind of improvement we have. I know it's a bit tiny for those that can see, or for those that are using that system. All these stories, everything started around 1950. So a lot of things were happening there, a lot of rule-based stuff, a lot of symbolic stuff in AI happened then, syntactic structures, different things being created. Between 1985 to 1997, now, the emergence neural network started changing things, because neural networks are part of the things that changed the whole AI. Before neural network, there had been a way of doing AI, but neural network changed everything about AI. And so in 1985, we had recurrent neural networks. In 1989, eating Markov models for speech recognition. In 1997, long short-term memory came in. So for recurrent neural networks, one of the, like I say, breakthrough made then. They were able to say, okay, how can we treat a sequence? You know, our language, our text ought to write a sequence. Yeah. So how can we treat a sequence? And when you're treating a sequence, you want to, for us as human beings, I've been talking for the past maybe 10 minutes. You will remember what I said 5 minutes ago. Whatever I'm saying now, you are applying everything together to understand what I'm saying now. So machine can forget easily. So how do we now make machine to remember the past so that it can actually have a context whatever it's doing currently? So they did some good work, but unfortunately, this particular model has a problem of vanishing gradient. So at the time, it had a problem with memory. So long short-term memory came, and that also brought an improvement, doing well. Yeah, but the only thing is that it can go in one direction. Yeah, so that's also a limitation. And so they brought in by LSTM, so which is like, okay, can you do both direction, which also changed a lot of things. And then between 2000 and 2018, we had more breakthrough in representation of information. So that was when we started having embeddings. So how do we represent information as vector and capture the semantics of that information? So we had a lot of breakthrough. Word2Vec came in, encoder decoder came in, which is also like a foundation for transformers that we're talking about. Then 2017, Google published a work and said attention is all you need. So if you can have a mechanism that can be able to remember and connect words to past words and understand relationship, for us as humans, these are very simple things, natural things that we do without any problem. Very, very simple. For machines, they are not simple things. So if you look at, use ChatGPT, whether 5 or 4, it's doing very well. But they tell you the number of months, number of days they used to train it. You will know. And they will tell you that the energy, you can Google it, the total energy consumed in training, not in now doing inference, but even in training, pre-training they did. It can be an energy that will power the whole of AI, or I don't know, or maybe like, let's say, I don't know how many houses, just to train. And you still keep on doing inferences and there. So what is so simple for us as humans to do, to get semantics, it's not as that easy for machines. It's a lot of work to do. So a lot of improvement came in, Word2Vec came in, attention is all you need came in, and that also changed the whole flow. And in 2018, a model came in, BERT came in, that could process text in both directions. And that also helped us now to have a better representation of text with context, showing relationship between all other words. And they started something called maxed input. What that means is that we want the model to predict the next word. So it's going to see a lot of documents, a lot of information, and want it to be able to guess if you see 1, 2, 3 words, what will be the next word. And that's also changed everything around NLP, because if you can predict the next word, then you can be able to be generating content. Yeah, so that's what happened. Then from 2019 to date, several models and architecture came up. Before we were talking about language model, now we're talking about large language model, but we're also going back again, talking about small language models, if you have been following the trend. Because we have seen that because of context, to capture context, maybe doing better with small language model than large language models. Yeah. Okay. Can we, please, you are free to stop me anytime and ask questions. I don't know the culture in your presentation, but you are free. I want it to be a conversation so that I don't go too far ahead. So we can always stop and have a conversation. Yeah. Okay, next slide. What are the NLP tasks? I mean, these are the, let me say, surface level now in terms of interaction, how human beings interact with this. So language generation, which is common today, everybody wants to generate content, generate things, yeah, which we have to use our brain and think before, but everybody now, nobody will claim here, I don't think anybody say he's not using ChatGPT or he's not using another AI to generate. So you don't want to waste your time creating letters, drafting things. It's only things that need your real brain that I want to focus on, yeah. So generating content, question and answering, and the machine is doing better now in question and answering. Unlike before, all this website I used to have, their chat in those days. But now today, machine is doing very fantastically well in that. Sentiment analysis, very important, especially to you guys, because you are dealing with customers. You want your customers to always like you. Customer intimacy. Yeah, so this is an important element for you. Machine translation, of course. In 2000 was it 8 or 9? I went to Japan for a conference. When you get to Tokyo, you can speak your English and survive. From Tokyo, I went to Osaka. You can still speak English and survive. But my conference was at Wakayama. Taking the train from Osaka to Wakayama, I saw a new word. I knew that English was not the most important language. Where you see, very important, but I was thinking anywhere you go to, you still find people speaking English. Nothing. It was very difficult. I got to the hotel. We were both using Google Translate. Google Translate 2008, you can imagine what it is. To communicate with the hotel, we were both using Google Translate. I would put my own. Yeah. I went to a shop, I wanted to buy something. She called somebody that could speak English. I would speak that one on phone, and that one I translate to the woman. But imagine today you go to China, you don't need all that. As you put it on your phone, she sees it, it comes to you in audio, she puts her own, and you are communicating. So a lot of things around machine translation has happened, all around NLP, to make machine to understand what we say and the other things. Then text classification is also another thing. Can we move to the next slide? Yeah. So, now, coming back to one of the things that changed the whole NLP research, transformers. So, It came in 2017 after this paper, Attention is All You Need. And it's actually changed the whole thing about how we understand text or audio, because now we're using them also for image processing, audio images. Yeah. The focus was heavily on text before, but now we're having it also for audios and images. So next slide. So this is what it looks like the simple architecture of what it has, but today we have more complex architecture, but just more combining these things in different form. They mix other things to it, so they also create what they call mixture of experts today, and they're also embedding that into it. But I will not go into all the details and maybe the mathematics there. So what is happening? Because the focus is about, first of all, understanding the semantics. That's the focus. Because if we can understand very well, then machine can take the right action. Yeah. So there are things around how do we process the data. So tokenization and embedding is part of what it's doing. And because we don't want just to be reading text from left to right and one by one, then positional encoding is another thing that they brought in, where now I can remember the position of a word I've seen where it was before. So I bring the position of the word. I also bring the embedding of it, and I bring everything together. It gives me the context of that particular word. Next slide. In the self-attention mechanism, there are three key things here, which is query, key value, and that's how we represent those information. For query, you represent the current token being processed. If you see a token, you can consider it as a word. It depends on the context. It could be a word, a single word. It could also be like syllables, so it depends. Key acts as a label for every other token, and then value contains the actual content of the token. So what we're trying to do, we're trying to use this to understand how do we represent an information in a vector form that the computer will understand that information and the relationship with that information and all of that information. So if I say information, you could take it as maybe a word or a sentence or a paragraph or a document. So today we talk about, before we started with word embeddings, now we talk about sentence embedding, talk about paragraph embeddings, we talk about document embeddings, and we're talking about corpus embeddings. And they're also talking about the whole world now. So let me leave that one. That one they're still thinking. Maybe when we get there, make some sense out of it, then we can come back to it. Okay. So by computing attention scores between the query and all keys, the model can determine how much to pay attention to each value and to understand how previous things you've seen relates with the current words you are seeing. So that's the kind of, next slide, please. So I've spoken about briefly what is going on. I mean, that is the masquerade. So now let's look at how that applies to us. How can we make use of this? Yeah, of course, everybody's not obliged to understand all the different things about the transformer. Yeah, there are so many libraries you can call and can solve these problems for you. You want to know the sentiments, either in the comments, reviews, whatever. I don't know how many reviews you get. Somebody says she's in customer support. How many reviews do you get on a daily basis, or tweets about you or things like that?
Sometimes 100, just several.
Yeah, Sarah. Yeah, assuming you are getting like 1,000, 10,000, 20,000, how many will you treat one by one? It's a lot of problems. So can machine filter for you? Can machine tell you the summary of what is happening every hour, every day, and you understand how are people viewing us? Or is there a new product about you there, and people are making comments, and you can automatically know this is what is going on about that product? So that was sentiment analysis is all about. What is the opinion of people? Generally, we say negative, positive. There are several other things. It can be angry, hate, so many other things. So it depends on how you want to categorize it. Yeah. But generally, we say negative, positive. So is it a positive comment? Is it a positive review they're talking about? Is the feedback positive? And so the machine can help you quickly analyze thousands, hundreds, or millions of data and tell you those that are positive, those that are negative. So what we did here, we just take some data sets, and we use three different models. This is SVM, a popular traditional machine learning model, SVM. We use TF-IDF as vectorizer. That vectorizer is what I've been talking about. How do you turn it to a vector that the machine will understand? So we have things that have been happening. Before we had embeddings, we have TF-IDF, another way is bag of words. And so we use another word, LSTM, which I mentioned earlier. And here we use embedding layer and embedding at about 5,000. That's the length of the vector. We also use BERT, and we use like With BET, the normal embedding can also shrink the size so that the processing can be fast. So let me not go into all the details about this. And so just to see what happens with sentiment analysis, can you go to the next slide? So based on data set, we use 3 different data sets, and it will be good also maybe to try on your own data set as well. From open data set from Google, and then this one is about customer complaints and sentiment and priority data set. This is financial sentiment analysis. This is label financial news data. So different kind of data set, and we'll try these models on them. Next. So generally in research, if you don't like this, don't worry. But in research, what is important to us in research is not just to build a system. It is about, are you changing the science? And also, how are you measuring performance? Whatever you cannot measure, you cannot improve. So it is very important to us to be able to measure. It's because if you can measure, then you can improve. So if I know I am at this point today, then I can improve it. So we are very interested always in the metrics. How do we measure? And I know the same thing you do in business. You have your indicators, everything you define, and you're setting your goal at the beginning of the year. So precision is one of the metrics we use in measuring the performance of our model in terms of sentiment analysis or any classification task. We use sensitivity. Sensitivity is the same thing as recall, and we also use accuracy. Well, for a layman, you may look at precision and accuracy. I don't know, almost the same thing. So, but for us, it's not the same thing. Precision, if our focus is on, we want to know what are the positive things. Precision is our major, what is the metric we're looking at. We want to see how many positive was the model able to predict correctly. So it's precision. Accuracy, we want to look at how many positive and negative was the model able to predict correctly. So not just positive, but everything we predict correctly, both positive and negative. That's what we're talking about. Now, in sensitivity or recall, we want to say, okay, if I want to break it down now. If I have 100 things here, 100 things, maybe 100 positive, how many can it bring out? It's not about the precision now. It's not about how precise it is. I bring 100 things in, and my algorithm, can it bring out the whole 100, or is only going to bring out 80? So I know that, so that's what sensitivity is talking about. So we use that to the next slide, please, to determine how our model is performing. And so across those 3 data sets, if you see now, so you can see that in terms of accuracy, well, they are not too far away. Recall, precision, they are not too far away as well for this first data set. For second data set, you'll see that this BERT is performing better than all other models. And also for this one, I think it's performed better. Why? This is using transformer. This is traditional ML algorithm. This also is like an extension of RNN. But all this came before this BERT. BERT uses transformer. So you can see that the transformer is helping them better in capturing semantics. So the improvement as the transformer models are giving us better results. So let's move to the next slide, please. Next slide. So this is another problem, financial named entity recognition. I will explain what entity recognition, named entity recognition means. Then I will also explain how can this be useful in terms of application. So this is about identifying names and entities in a document automatically. So machine can look at millions of documents and begin to bring out this is a country, this is a state, this is the name of a person, and this is this and that, this is an organization, and the rest. And with this is also not something so easy, but for humans it's easy. But when it's easy for you, maybe you take a page and you can easily do it. But when they bring 1 million pages here, you cannot do anything. So you understand? But the machine can handle that maybe in a few minutes. So that's where the machine work is interesting here. So this is a subtask when it comes to relationship extraction. Business news are coming. I know you follow business news. Of course, you must. So business news are coming, different are coming. If there's a way you can extract the information automatically coming from the business and relate with entities of interest. Then you make some sense automatically from the different sources of news you're getting from. It gives you a summary and you know what to do instead of going through maybe, well, you can imagine, let's say 10s or 20s or 100 of sources. So doing name entity recognition and going further to do information extraction and relationship extraction, then you can bring out insights from document. All these are part of NLP tasks we do. So we also try that for some data sets. So we use BERT, Model, and Llama. I know you understand Llama now if you have heard about Llama. We use BERT, Model, and Llama, and we use Adam W optimizer for them. And for our loss function, we use cross entropy. Okay, it's okay. This is about the results. You can see this as example of sentences in the data set, and this is kind of what is bringing out as the entities is identifying from data set. Let's move to the next slide. Yeah, thank you. Okay, machine translation. Yeah, this is a very interesting part. We are evolving in this aspect, but we're not yet done. And I will tell you why. We're evolving. A lot of things happening. It's better, it's become better, but we're not done. Yeah, because we are doing well for 3 major languages. So I'll come back to how that relates to us later on. So how do you translate text or audio automatically? It's another NLP task. And so quite a number of, this is Yoruba, quite a number of models are doing that now, translating. So if you look at this now, if you try OpenAI and you also use Google, I can see both of them. They're not doing badly, but they are not still getting very well in terms of our own languages. But they can translate the document. You can see the translation from Google, OpenAI. Google started BERT, so definitely they are also using Transformer. So you can see OpenAI, we know that, of course, yeah. So you see the translation. There are some little things, but the general meaning is still there. So, previous slide before this. Okay, you can go to the next slide. I'll come back to connect all these things together later on. What about financial question answering? Whether question answering generally or financial question answering, which is another good one area of, application area. Yeah, where you take data set or all your data, you can prepare your data based on what you have, and you label them, you generate questions and can say, and generate answers, the right answers. You have data set, you train the machine. So when people come later on and put questions, instead of, hey, let me not say this one because people don't like it. Well, whether you like it or not, it is a reality. People will lose jobs, it's normal. But there are several new jobs that will be there. So we have to understand, this is normal. Anything redundant, anything that is not, that machine can do better, will definitely move to machine. So, but there are more opportunities that will come. So there are ways of improving our productivity and efficiency that we can get the machine to understand how to answer questions correctly and answer good questions. And so it's only things that is creating problems that will escalate to humans. And then we can do more work and solve more problems. So this is part of what NLP can do for us. And so this is an example of what we did. We took some data set and trained the models and checked the accuracy. If you look at this window, it's getting, the participants are blocking that. You will see the performance of the model in terms of accuracy. Yeah. So, of course, we are aiming at 100%, but it's not so easy to get 100%. So, human beings, most often, I don't think you're 90% correct. As humans, I don't think you're 90% correct in what you do every time. So, if machine is getting close to 90%, it's not too bad. Yeah, it's doing pretty well. Okay. Yeah. So this is just an example of the kind of question thrown to the model. Not before this one. Kind of question thrown to the model. What's the value of the one-time transaction tax payable by the company? And the model gives the answer. So next slide. Now, bringing everything together. How can it make sense, especially to a company like you? Getting insight. All those things I mentioned are like scattered things, but it's about combining them together that will really make sense to you. So I've talked about sentiment analysis, sentiment detection, talk about translation. So if you have customer complaints or whatever textual data or whatever data you get from customer, from reviews, whatever, and you perform all this on them, category detection, priority detection, sentiment detection, and then you incorporate NLLM or transformer, whatever you want to incorporate in. Yeah, because all of them are based on transformer in, and you can be able to generate insights that will help you to better attend to customer. If you automate it, then the machine can attend to customers when it's necessary. And also, the machine, based on priority, you're able to detect automatically what is the priority of the complaint or what the person is saying. The machine also can escalate what a human being should be treating and say, this one, you need to attend to it. Yeah. So this is possible as well. And this helps you to have better insight from the data you have. Next slide. Taking this data, doing all those things I mentioned, the sentiment level, sentiment is neutral, priority level is urgent, product category is debt collection. And then also now you've used some models to do some classification work on this. And then you are now plugging in a transformer or LLM or a small language model into this. Next slide. Then proper insight comes in about what the complaint coming from the person. So it's interpreting everything to us now. The customer reported a debt they did not recognize and attempted to dispute it. The process for disputing the debt was burdensome, requiring an affidavit, blah, blah, blah. And that is, so it's telling us not only just what is said, but categorizing them on the different issues in that problem. So there's a problem of disputed debt handling. There's also communication and notification failures. The customer was not notified about the legal proceedings because correspondence was sent to an outdated address. That's why the company having the correct address on file from a recent payment. So it shows there's also a problem with the company in the database, whatever people are asking. So the insights keep coming. Data management concerns. There is a clear breakdown in maintaining and using up-to-date customer information. The use of an old address for legal notices when the current address was available suggests poor data management and a lack of cross-reference. Next slide. The customer impact. The customer suffered a financial loss of $830 levied from their account and emotional distress. Of course, 2 days ago in my office, a lady, she got a new job with a bank. She was to start, and they sent her a message that maybe they were doing a credit, whatever, check, fraud or whatever. That they said she owned a company, one microfinance company, 400,000 naira. That she collected 2,000. She collected some money to 2020, and she said she never did it. But I was in 400,000. She started crying. I was wondering because one, the bank said that they are not going to give her she has to go and clear that before they can give her an offer letter, before she can resume. So she started crying. So what am I bringing up from there? Is the emotional distress. It can be worse than even the financial. Yeah, because 400,000 is small. To her, it's not small. But she started crying. Everything she wants to do now, she doesn't. I mean, she's like, she couldn't move forward. You understand? So that could be much more disturbing than any other thing. So this and all this can be handled. Machine can help us to handle some of these things. So process improvement opportunities. The dispute process should be reviewed to ensure. So apart from analyzing the problem, it also gives you things you can do to improve your processes. So actionable insight. Simplify and support the debt dispute process to encourage timely resolution. Implement robust address verification and update protocols before legal actions, and every other thing listed there. This is just from an example of a complaint. So next slide. Yeah, what's next? With all this explanation, we're in Africa, over 1 billion. Africa, we are not, most of our languages are not really written, only few are written, it's spoken. So it's multimodal that will make sense for us in Africa. And I know you are interested in financial inclusion. If you are really going to drive that vision, it's about multimodal. Yeah, spoken, acoustic data. So how do you do, so what we currently do now, the work we do now at our lab is more of AI localism. How do we build models that understand our context? That's what the focus on, because that's what can actually benefit our population as we move forward. That the benefit of AI, we can maximize it for Africans. And so look at all this, if you are saying you are using Alexa, you are using all these things, you cannot speak your language to it and you understand. You understand? So the productivity they are gaining, we can get it here because, you went to school, we can speak English, fine. But we are not the majority. So if you want a better world, and I know with all your services is what you are looking for. So if you want somebody, the POS guy, to be able to take advantage of AI, then we need to make sure we can capture its context properly. And that's about AI localism. It's a lot of things, but I think it's the direction to go. And that is when now this can make sense because people can complain. Many people are not complaining today because of complaint channels are problems for them. Yeah. Even when you can speak English, you still look at when you want to complain about something, you still feel like you do this, they will send me here, is a problem. So now that you can't speak English, then it's a big problem. Or you cannot write. So why should it be a problem? Why can't, the way they are using it, they are WhatsApp in market and they just send a voice message and everything, business continues moving. Why can it also not be done in this age of AI? So these are the kind of problems we are solving currently. So next slide. I think, that talks about it. And these are the problems that's making it difficult for our local languages for us to solve this problem. But of course, since these problems are there, absence of standardized orthography, paucity or absence of digital corpora, little representation in formal education systems, absence of web scale data. Yes, but we can still work on what we have and focus more on the lived experience. That's why acoustic data is key, and be able to create models that will serve our own continent. I will end here. I'll stop here and take questions. Thank you for listening. Yeah.
So I'm not sure if you touched on that because I stepped off for a bit.
Okay.
So there's the whole concept of fine-tuning.
Yeah.
Right? And I do know that fine-tuning is not like a one-size-fits-all. It doesn't solve all your problems. The thing I'm not quite sure of, there's this whole form and facts, fine-tuning is better for form, shape of the, training something to understand the shape. Right? So in what cases do you think is most efficient to go the fine-tuning route as opposed to prompt engineering so that you can...
Okay.
Yeah.
So I will explain it this way. The LLMs, they generalize. Let me say generalize. They have a general understanding of language. They are very good at that. If you are going to create your own model now, you are going to do a lot of work to create that general understanding of language. That's semantic I focus on. So now when it comes to your specific context, like for example, financial data, you want it, you are taking a model that has been pre-trained, that has a good understanding of language. You are not trying to make it understand the financial language, financial things, specifically things related to your own. So that's where fine-tuning comes in. So what we are changing is that you are modifying the models have parameters. Yeah. So you are trying to modify the parameters. So it's more like you are adapting it to your own data so that you understand your data better. And so it's not going to give you general knowledge. So it's like it has learned general things, that's general knowledge. But now you are making it to learn your own specific things. So when it's answering your questions or it's helping you to plan things, it's not using general knowledge. It's using general knowledge that has been shaped by your own knowledge.
Yeah,
okay. So you can either fine-tune, you can do prompt. Prompt-tuning is another way of fine-tuning, but at that level, it's not that you are training per se, but it's like context. Now you are using some prompts to help it understand how to behave. So it depends on the context.
Yeah. So that's the thing that's difficult because I've tried to fine-tune something before.
Yeah.
And the mistake I was doing, or what I think is a mistake, was trying to fine-tune it to understand the facts about my domain. What I mean by facts, specifically what I was trying to do was there's a schema, data catalog, for instance, and I needed it to be able to tell me based on natural language, how do I traverse, how do I search, what tables, what's the select statement or query, right? Okay. And I gave it a bunch of examples. It was great at giving me the output in JSON. That was correct, but the actual queries were not correct.
Yeah. So did you do that? It was fine-tuning, you do prompt tuning?
So when I did fine-tuning, it didn't work. Yeah. Prompt tuning, I gave you the entire context, but the problem is the context window is large, depending on how many data sources you have. Yeah. So managing that context is difficult. So I'm trying to understand at what point is fine-tuning, not prompt tuning. Yeah. At what point do you go for prompt fine-tuning? I know if you wanted to understand Hausa, for instance, and somebody understands English, you can do fine tuning there because it's a structure. It's related to structure. Maybe I may be wrong.
No problem. No, go ahead.
But like that's what the way they understand is you fine tune when it's a form problem, is the form, and you probably prompt tune when it's the fact. But if your context is very large, then how do you prompt tune? Because then your token is going to end.
So fine tuning also depends on the size of the data, because what you want it to learn, can you learn it enough from the data you have?
True.
Yeah. So if your data is not big enough for you to learn very well, it will not. It will give you some output, but it may not be totally correct.
Yeah,
so if you want to do fine tuning properly and want it to be good, and want it to give you a good response, then make sure the data set. Of course, you are not going to be using for millions or billions, but if you get like hundreds of thousands, then you should be able to get a good performance.
That is expensive.
Exactly, that's the problem.
If you do it wrong, I just stopped because I tried 10 times, $50.
So your data size, maybe, I don't know.
No, it was like in the hundreds.
So that's one of the problems, because it's not having enough data to learn what you want it to learn. So do you know this? The reason why, just to give you also something from the research we are doing currently, the reason why these systems can write English better than us, and the English is not, you don't see much error in the English. You can have error in the context what it's saying, but in the English, is because it has learned the grammar of language from data. It has seen, I don't want to say billions, but millions of written text, the whole of Wikipedia, all of the data. So it has learned the right grammar. So it will write correct English for you, but it may not write correct Yoruba language because we don't have enough data for you to learn the grammar of Yoruba language. So we still have to support it. So that's something we do now. We do something on computational grammar to support the models we are building for our languages, to support it in trying to understand grammar. Because when you are making it, until you have that large corpus that you can learn everything automatically from data, you will still be making mistakes.
Right. So how do you train your model now?
So what we do for what we are doing, yes, fine. So there are two different things, and because it's research, it's not. That's the difference between us. We are not going to focus more on the application at the beginning. Yeah. So we're going to be trying different methods and see which method gives us a better result. So when we do fine tuning, we will also try to do small language models where we can even train a model totally from scratch. Because we want to look at which one gives us better performance. But there are also some multilingual models that have been created, which they've used several languages. So the other thing we're talking about is transfer learning. So if we have languages that have been in the same family, most of these languages in linguistics, we have families of language. Okay. So there could be some common characteristics. So there are some models that have been trained, algorithms that have been trained on several languages. And if there are languages in our family, then what we can do is now bring in more data sets and fine-tune them. Right. So we look for more data sets in our own language and fine-tune. Of course, they've understood our own grammar a bit, but we can now fine-tune it better to give us more results.
Okay. Which is also you don't like do the feature engineering for the training. You just fine-tune on top of existing
At this level of LLM, feature engineering is not so much needed.
Fair.
Yeah.
All right.
So, but from because we're talking about languages, you're talking about textual documents. So it depends on what you are doing. So for your problem, it was clear. You are looking at your schemas and everything. So, but for this one that wants to understand language, feature engineering is not much of the problem.
Okay.
Yeah.
So clustering or.
Pardon?
So okay, you just.
No, go ahead.
I'm trying to see the different approaches you took. You see, you mentioned the small language models that you fine tune. And then large language models that you fine-tune.
You can build a small language model from scratch. You can also fine-tune a small language model. It depends. Yeah. So if you have enough data and you have the compute power to do it, because compute power is another problem. So you have the data, enough data and compute power, you can start your training from scratch.
Right.
Yeah.
Okay.
But if you don't have the compute power and you don't have the data, then you fine-tune existing. We just make sure, what I think you should keep doing is, data is the most expensive task here, with data and compute. That's why the data business is very important. So, and it has to be intentional. So now that you've seen what you want to do and you know that it's relevant to you and there's no model that can do it for you the way you want it, then you have to invest in the data part.
Yeah, it's very expensive.
Yeah, it's expensive, but you have to keep doing it, because if you look at what it's going to help you to do in the future, then you do it.
All right, fair point.
Yeah, what we are benefiting from today, a lot of investment in data, and you see there's still a lot of money in the data annotation work. I have a new AI startup company that started. It's not my own. I'm just advising them. Yeah, that started incorporated in the US, also incorporated in Nigeria. It's a data annotation work because it's going to determine how these things will go. Yeah.
All right. Thank you, Toby. Thank you, Dr. Peter. So someone has a question. Babatunde Owe, concerning the financial question answering.
Yeah.
Is it like a RAG implementation or approach? Is it trained from scratch for the use case or was it fine-tuned? What approach would you recommend? Typically, an approach that can also solve data access issues in terms of who is able to get response to what question would be appreciated.
Okay. RAG is retrieval augmented generation. What we did here is we combined some models to do all the first three things: priority detection, sentiment, and category detection. Then we use LLM now to work on the insight, and also generating it, explaining in a way that someone will understand what that means. So if you want to do something like that, RAG is okay. You can use RAG. You know why do we use RAG? Because when the model is limited, because it's pre-trained, it's whatever it has learned. So if they trained last year, it's knowledge of last year it has. But if you go to their interface, they're all doing RAGs now. If you go to their interface and put questions, they also go and search the web. So everybody's doing RAG. But if, let's say, you take an open model and you are using it for your own problem, yes, you can fine-tune it. But when, let's say it is 6 months old and there are new data, new information, then you need to bring RAG in. Yeah, so that's what RAG comes in. RAG is to augment. The model learns, but you can't train model every day. It's not possible. If you spend 2-3 months training a model, you can't release it today and come and start training again the following day. So it's going to be here for a while. And so new information coming in, it has to use RAG to be able to integrate the new information into what the model, the knowledge, the brain of the model. So it depends on the problem you are solving. If you want to do the insight and new data that you have to learn from, definitely you have to bring in RAG. Understand? So the model can suggest, can bring things, then you can also use RAG to look at what is the current reality, the database. For example, your database now. You want to put your database, allow LLM to access your database? No. Yeah. But you can write your own, you can do some prompting that from your database, there are some things you are bringing out, and you are creating a system between LLM and your database. Yeah. So in that way, your own context, you are bringing it into general understanding LLM as to be able to generate the insight. Yeah, so that can also happen. And at the same time, you can have your own, you can take a model, open model, and fine-tune your data and host it locally so that on your own, you use it. And so that means the knowledge from your data, you don't want it to go out and it stays within your company. Yeah.
You mentioned about the effect of having our local intelligence, especially the fact that most of our language is not written, is spoken,
yeah.
Right? And then we have most of our people, the people that are unbanked, thinking from a solution point of view, if you are trying to interact with these people, you're going to be using language with it, right? But we don't have the resources now. I'm taking it from a high level now. We don't have compute resources. We don't have the data as well. And I don't see any government initiatives that is trying to bring all of those resources together to kind of solve this problem. So is there anything from the academia point of view, from your experience, since you've gone really wide, are there any opportunities for people to attack this space? Because it seems like Africa is going to be left behind in this race as well. There is the Stargate project I heard in the United States, $500 billion being poured into research, poured into data centers and things like that. And we've not even scratched the surface on developing one model. So do we have a chance? That's my question. Does Africa, in your opinion, does it really have a chance to fight this AI race?
The first thing is intentionality.
Mm-hmm.
Nothing happened by chance. You have to be intentional about it. So you mentioned it, they have $1 trillion because they know what the future, everybody wants to control the future. Mm-hmm. So if we fail to do it, we will still be slaves I mean, forgive me. We'll continue to be. Yeah, that's the reality. They don't need to come here and put chains on us. Yeah, we'll just continue to depend on them. So a lot of forums, we have a lot of platforms now. So the key word about that is the reason is collaboration. You can't do it alone because a lot. And we don't need to compete with them. We need more small language models. Yeah. So we need to focus on what we need and collaborate, industry, academia, and work together. Most of the grants we get to do research, it comes from outside the country. That's everything we know. Exactly. Meaningful grants. So I'm not talking about somebody saying he's giving me 25 million naira. What will I do? 5 million. Like what they did the last year, 5 million naira. What will I do? 5 million naira. I can't enter the conference. My flight ticket to attend the conference, 5 million is gone. So that is attending a conference. You won't talk. Talk less of what it takes me to pay PhD students. If you don't pay PhD students, they can't get results. If you don't pay master students to do research, you can't get results. And if the researcher does not have his own honorarium, he will be looking for money. So he can't do a thorough research. So most of the meaningful grants we get are from outside the country. 500 million Canadian dollars, 1 million Canadian dollars outside the country. So they are still the one who funded us to do research for our own local problems. You understand? And so that must be that intentionality there. We want to make sure, we want to serve Africa, we need to understand it. So both the business world and the academia and also philanthropists should come together. Our government, I don't want to go into the story, but we know, they are trying to do something, but I think they still have a long way to go. So that is there. So collaboration is key, I will tell you. That's the most important thing. Now, about data now, before, people are not really, they are talking about open data, but now everybody is now talking about, since OpenAI did what they did, benefited from open data, and they are making a lot of money, everybody is trying to also keep their data.
Protect it.
So now, the problem is about data licenses. So they're saying, so if you go to just use Nollywood from YouTube, you have problem at the end of the day. Exactly. So data license is another thing. Even now, people that are curating, some people are getting grants and curating data, processing it, annotating it, making it open, but there's still a license. So if you're a company, you want to use it. If you're a company generating a lot of money, they say pay. I mean, some people paid money to get this done. But if you want to do it for research or you're a startup, they are not yet making money, then they can give you to use. So all this, we have to be part of the whole ecosystem and support it. So we can get there. I'm not having any doubt because I'm seeing, I'm in part of different community and also participating in different kind of fora. We are having conversations, so I know we are pushing towards it. We have evolved beyond where we were before. So we're moving towards it, but we still need a lot of resources. But we don't need to compete with them in terms of AGI. They are competing, they are looking for AGI. We still need to see how the normal intelligence that can help us solve problems that make us be more productive. A Suya seller can be able to use AI. If you go to any LLM now and ask questions, I have 100,000 naira. I want to do a business. I'm in Ajigule. What can I do so I can multiply this 100,000 naira to 1 million naira within a year? You cannot get really contextual information. So that means our common man cannot really benefit from AI. Whereas in their own context, you can really get something more contextual that can be more meaningful as a business, and you go about doing the business and make money, and your life will change after a while. So